real exam questions. This is question 63, and it's about slab reinforcement. A rectangular slab is supported on one side, A, and partially fixed on the other side, B. After plastic analysis, the following reduction elements are obtained per meter of slab width in ultimate limit state persistence. Determine the reinforcement at support A and support B of the slab. The reaction force at A is 58 kilonewton per meter. At point B, it's 117 kilonewton per meter. The maximum bending moment at support B, or the negative bending moment, is 20 kilonewton meter per meter, and the positive bending moment is 68 kilonewton meter per meter. The slab is 280 millimeters depth, a concrete cover of 50. The diameter of the reinforcement perpendicular to this reinforcement, these are the small dots, is diameter 10, and the concrete quality is 20 megapascal. We start with HE. The effective depth of the slab in the vicinity of HE is the total depth of the slab minus concrete cover minus point of gravity of the reinforcement, and it gives you 225 millimeters. The reinforcement at the or in the vicinity of HA must be at least half the reinforcement needed for the positive bending moment. So, and this reinforcement is then the bending moment times 10 to the 6 because of the units, divided by the lever arm, which is 0.9225 divided by the yield strength of the steel. Why are we using 0.9? Well, because the reduction elements are found with a plastic method, so by yield lines, for instance. So that's why we can easily use this factor 0.9. It gives you 386 square millimeters or 4.9 bars of diameter 10. That's the first calculation. The reinforcement at the HB, in the vicinity of HB, must also fulfill the minimum required reinforcement. And the minimum required reinforcement is given by this formula. And you can substitute with the different elements, and you got 259 square millimeters or 3.3 bars per 10 meters. But minimum reinforcement must be the minimum of three elements, the maximum of three elements. Or it must be 1.3 times D, which gives you 3.7 bars of diameter 10. Or it must fulfill this equation, and we end up with 3.2 bars of diameter 10. So we take the maximum of those three. So the minimum reinforcement is 3.7, and round it off, it means 4 bars diameter 10 per meter. Then, of course, at HA, we must fulfill the stability in the sense of that the support must be able to take, or the reinforcement over the support must be able to take the reaction force by pure shear. So it means that the reaction on that HA was 58,000 Newton divided by the maximum allowed stress, which is for shear force, the yield strength divided by square root of 3. And so we need at least 231 square millimeters so that the support is mechanically fixed. And this gives you 2.9 bars per 10 meter. And then the calculated reinforcement, it means for a bending moment in the vicinity of point A, which because it's simply supported, it's 0. So now we look at this and take the maximum of it, and then we see that for the positive bending moments, the maximum is equal to 4.9, means 5 bars diameter 10. And for the negative bending moment, it will be 3.7. It will be 4 bars diameter 10. Now we look at HB. the reinforcement HB must be at least half of the reinforcement needed for the negative bending moment. And this is the negative bending moment is 68 kilonewton meter per meter divided by the lever arm, 0.9 times 225. And we end up with 4.9 bars, diameter 10. We look at the minimum reinforcement. We have 3 numbers for that. The minimum reinforcement is of course the same as in the previous slides because the slab thickness is the same. So it's exactly the same what we've done in previous slide. And for shear, we have a reaction of HB of 170 kilonewton divided by the admissible stress for shear, and we end up with 5.9 bars, diameter 10. The reinforcement at HB and the calculated reinforcement is then for the negative bending moment is 20 kilonewton meter per meter divided by 0.9 times the effective depth and divided by the yield stress of the concrete. It gives you 2.9 diameter 10. So in summary, for the positive bending moments, we end up with 6 bars, diameter 10, and for the negative bending moments, we have at least 4 bars here, 4 bars.